Yeah, hello everyone. So in the previous video, we have discussed about the pre-order traversal. Today we'll discuss about the in-order traversal in a binary tree. Now, these videos are very important actually, because in the tree, if you know about the traversal techniques, every question is based on the traversal only. Because whatever you want to do in the tree, you need to traverse the tree, right? So for traversing, there are different techniques available like the breadth first search, depth first search. As part of depth first search, there are three techniques: pre-order, in-order, post-order. In previous video, I have discussed about the pre-order. Today, I will discuss about the in-order traversal, which is also very important. So you need to spend a lot of time just to master these traversal algorithms. So let me start with the in-order traversal. If you haven't watched my previous video on the pre-order traversal, you can check out that. So today I will discuss about the in-order traversal. Now, what is in-order traversal? In-order traversal is one of the depth-first traversal technique in binary tree. So what order we need to follow here is, first of all, we will go towards left side of the root, then we will print the root node, then we will go towards right side of the root. So this is the order which you need to follow. So let us just apply this order into this given tree so that you will understand how it is working. So what I mean to say is, let's say this is the root node. Okay, what you will do from root, you will go towards left side of it. So from 1, you will come to the 2. Okay, from 2 also you will come to the left of it, which is 4. Now, since 4 doesn't have left child, so you will just print the 4, which we have done. Okay, so we have printed the 4 here. Now you will go towards right side of 4. Since 4 doesn't have right child also, what you will do, you will go to the parent of 4, which is nothing but 2. Okay, so since left side of 2 is done, what you will do, you will print root, right? So you will print 2 now, which is second node, which you have printed so far. Now you will go towards right side of 2. So from here, you will come to the right side of 2, which is 5. Now, again, 5 doesn't have left child, you will print 5, right? You can see here, we have printed the 5 now. Now 5 is done, 5 doesn't have right child, you will go on the top. On the top where, since 2 is already done, so this subtree is already done, right? Where you will go at this particular node, which is nothing but your 1. So what you will see here, left side of 1 is completely done, right? So we will just print 1 now. So you can see we will just print 1 now. And now we will go towards right side of 1, which is at node number 3, right? Here again, you will apply the same logic. So what you will see, you will go towards left of 3, which is 6. And you will print 6 now. You can see we are printing 6. Then we will print the root, which is 3. Then we will print the node number 7, which is the last node in the tree. And this is the how we will do the in-order traversal. So the output of this is, okay, output of this is nothing but this particular thing. All right. So what is the output? Output is nothing but 4, 4, then 2, then 5, then 1, then 6, then 3, then 7. Understood? Now how to write down the code? That is the important part which you need to learn about. So we can have two different techniques to solve this problem. One is your in-order recursive solution. Second is your iterative in-order traversal. Let us jump to the recursive part first of all, because that is very easy. So in the previous video, I have discussed about the pre-order recursive solution, which is, so this is also exactly same to that. The only thing which you need to do here is, here, instead of printing the root, okay, instead of printing the root before the left tree, you just need to print it in between the left and the right side. So what I mean to say is, here what you will go, you will write one function, let's say in order, in which you will pass the root node. Okay, the first step you will do is you will call the left side with the same function. So what you will do, you will call the same function with the left node. Okay, root dot left. Now you will print the data. Because left is done, you will print the data. Now you will call the right child in the same function, right? Now, what is the first line here? In every recursive solution, you need to write the base case, otherwise your function will never end. It will keep calling. So definitely you should have one base case, which is nothing but the stop condition for your execution. Okay, so that is the part. Now okay, let me quickly jump to the coding part. I will explain you how it will really work in the code. So this is the pre-order traversal. Okay, so this same code I have explained in my previous video. Now let me explain you the code for the recursive in-order traversal. All right. Now this is the code which we have discussed in the previous video, where we have discussed about the pre-order. What we are doing here, we are printing the root data first of all, then we are calling the same function with the left side, then we are calling the same function with the right side. Now, instead of doing this, what we need to do in case of in order, let me just explain you with the help of code itself. So let's say the method name is in order. In that, what you will do, you will just, so base case will always be same. This print condition, we will move up to the left and we are done, right? So that is the only change which you need to do, and you will say, hey, it's working. So from here we are calling, let me just show you, are we getting correct output or not? You can see we are getting 2, 4, 5, 1, 3, 6, and 7. Okay, so 1 second, let me explain you from here. Are we getting the same output? No. Why we are getting 2? It should be this one, right? 4, 2, 5, 1, 6, 3, 7. Did we miss something? 1 second, we can quickly check it. So we are calling in order with the root node, and our tree is also same, 1, 2, 3, 4, 5, 6, 7. Okay, 1 second, we are calling in order with the root, and if, oh sorry, see, we are calling pre-order here. So this is the mistake which I did. You just need to change the name of the method. Now let us quickly run it. So you can see we are getting 4. We are getting 4, 2, 5, 1, 6, 3, 7. Okay, so 4, 2, 5, 1, 6, 3, 7. We got it right. Now this is the about in order traversal. Okay, and now the most important one is how to do the iterative. What is the iterative in order traversal? In the iterative in order traversal, we will not call the same function again and again and again. Okay, instead of that, what we need to do, we just need to run a loop. In that loop, somehow we need to manage the things so that we can traverse the full tree in the order left, root, and right. Okay, so let us explain. Okay, let me explain with the help of example. So what I was saying is, let's say you are at the root number 1. Okay, what we are saying, we will go towards left side. So from here, you will go to the node number 2. From here, you will go to the node number 4. From here, left is nothing, you will print the 4. You are done with the 4 node now, because 4 doesn't have right side. Now, how you will go to the parent of 4? Okay, because in case of recursive solution, we were going to the parent. How? Because of recursive way. In the previous stack of the we were at the node number 2. That's why we were able to go to the parent of the 4. But in case of iterative, okay, let's say you reach to the node number 4, you have printed it. How you will go to the node number 2? So somewhere we need to store it, right? So here, what we need to do is very simple. Once you were coming towards downside, okay, that time just keep storing the data also. So for example, first of all, you are at node number 1, store the 1 into the stack. You will go towards left of 1. So you reach node number 2, store the 2 into the stack. Then you will go towards left side of 2, store the 4 into the stack. Absolutely correct, right? Now 4 doesn't have left child. It means your root become null now, because you will do root dot left. So you reach this particular point where root is null. Whenever root is null, you need to pop the element from the stack and print it. So you will print 4 here. Okay, right. What you will do after printing, you will update the root as the popped element dot write. So popped element is 4. 4 dot write is again null. So again you are getting null. It means you need to pop the element from the stack. So what you will do, you will get 2. Now once you are popping element, first of all you need to print it. Then update the root with the root dot with the popped element dot write. So here 2 dot write is nothing but 5. Now you will insert the 5 into the stack again. Now here we reach to the point number 5. Here 5 doesn't have left child now. So your root become null. You will come here, your root is now null. What you will do now? You will just print the node number 5 now. So we will print the node number 5. Done? What you will do now? You want to go, okay, your root is null because 5 write is null. So you will pop the element from this stack, which is nothing but 1. So pop the element 1, print it here, and update the root as the popped element dot write. So you will reach to the row number 3. Again insert 3 into the stack. So you will insert 3 into the stack. You will go towards left side of 3. So you will insert 6 into the stack. Now 6 left is nothing but null. You will reach here. So root is null. You will pop the element from the stack. So you will pop 6 from the stack. Once you will pop the element 6 from this stack, you need to print it first of all. After print, what you will do, you will update the root as the popped element dot write. So write of 6 is also null. So again, you will print the element from this stack, which is nothing but 3. Pop the element and print it. First of all, you will print it. Okay, sorry for my handwriting. So you will print 3 here. And what you will do now, you will update the root as write of the 3, which is nothing but 7. Okay, so you will insert 7 into the stack here, and you will go towards left of 7, which is null. So since root is null, you will pop the element from this stack. You will print it now. Okay, you will print it now. Now you will update the root as the write of 7, which is also null. Now root is also null and stack is also empty. Okay, you can see there is no element into the stack. It means we are done. So this is our output 4251637, which we have seen, right? So this is all about iterative in-order traversal. Let me quickly jump to the coding part. So here, what I was talking about, this is our pre-order traversal. If you haven't watched that video, please check out that video first, because these are somehow related to each other. And if you will understand this pre-order first before coming to this video, it will be easy for you to understand it. So this is the code which we have written for the pre-order. In the pre-order, what we were doing, when we were going towards left side, that time we were printing the node. Okay, here you can see line number 34. Because we are going to the left side, we were printing the root, because in case of pre-order, order is print root, then go towards left side, then go towards right side. But in case of in order, what we are saying, first of all, we'll go towards left side, we'll not print it. Once left is done, then we will print the root. So we will always print the data just after the pop. Okay, that was the thing which we have seen here, right? So now I will just copy this piece of code. One second. We'll see how easy it will be. So here, let me just write down in-order traversal. Okay. What we are doing here is, instead of printing the data here, where you need to print out, you need to print just after the pop, or you need to print the pop element always. And we are done, right? Let me just call this method from the here. Okay, let us run it. We'll see. 4251637. Got it? So this is how we got the answer. So these two are very simple. Okay, here we are just printing the data before inserting into the stack. Or here we are printing the data just after popping the element from the stack. So this is all about the in-order. So I hope everyone it is clear now. Okay, so if you feel anything is still not clear, please comment out. I will be happy to help you. Or if you want to make, I should cover some more topic, or what topic you feel which are difficult for you to understand, please comment out, please let me know. Or if you will share any feedback, any suggestions, any improvement which I can do, please let me know. All right. Enjoy everyone. Happy learning.